Hello everybody, welcome into another lesson. So today we are going to solve systems of two quadratic equations. So what is the goal of doing this? Well, in the last lesson we had a system where there were two equations, but one was linear, one was quadratic, and so in the last lesson the goal was to find the intersection of a line in a conic section. In this lesson, we're going to figure out the intersection of two conic sections, which could be more than one point. So let's look at what we got here. We have negative x squared plus y squared plus 10 equals 0. Then you have negative 3y squared plus x plus 1 equals 0, okay? Well, first equation is definitely a hyperbola, second one's a parabola. So we need to figure out where a hyperbola and a parabola intersect, if they do at all. Now, you could do substitution. You could make x equal to 3y squared minus 1, but if you do that and put that in for that negative x squared, you're going to end up with a fourth degree term for the y. I wouldn't suggest doing that. What I would, however, suggest doing is both terms have a y squared. I would try elimination. That's what I would try. So first multiply the top equation by 3. If you do that, you'll get negative 3x squared plus 3y squared plus 30 equals 0. And then you would still have negative 3y squared plus x plus 1 equals 0, okay? Now, if we subtract the if we add the second equation to the first, we can eliminate the y squared. So let's go ahead and add the second to the first. If we do that, you'll end up with negative 3x squared. The y's are gone. Then you'll just have plus x plus 31 is equal to 0. Well, you can definitely factor out a negative 1 from this and get a 3x squared minus x minus 31 equal to 0. So let's do that. Well, unfortunately, we're stuck using the quadratic formula to solve for x. So x would equal the negative of b, negative negative 1, that's positive 1, plus and minus the square root of that b squared, which would be negative 1 squared, minus 4 times your a of 3 times your c of negative 31, all over 2 times your a of 3 would actually be 6. So then you'll end up getting 1 plus and minus the square root of 1 plus 12 times 31, which will not be pretty. I promise you that. It's not going to be pretty at all. That's 372 all over 6. So that would equal 1 plus and minus the square root of 373 divided by 6. Well, what I would like to know is, does 373 break down any further? I'm checking now. Nope. It doesn't. So this is literally, you have two answers for x. So, yikes. Now pick an equation to substitute this value in for x. Well, let's do it. So what you'll end up getting is negative 3y squared. Let's pick your first x. x1 would equal 1/6 plus the square root of 373 over x. Let's see if we get anything for that. So you'll have plus 1/6 plus the square root of 373 all over 6 plus 1 equals 0. So that would give you negative 3y squared would end up equaling negative 7/6 minus the square root of 373 over 6, which would have to mean then that y squared would equal positive 7/18 plus the square root of 373 over 6. So then y would be equal to both plus and minus the square root of this whole thing. The square root of 7/18 plus the square root of 373 over 6. So yes, you end up with a square root inside of a square root. You can totally have that too. Sometimes you will have that. So you'll end up getting two x coordinates right out of the gate of, you'll have one x coordinate of 1/6 plus the square root of 373 over 6 for your x coordinate, but you'll have, for that one x coordinate, you'll have two y coordinates of both plus and minus the square root of 7/18 plus the square root of 373 over 6. So those are 2 points of intersection. Now we need to figure out when the second x here, this time, is equal to 1/6 minus the square root of 373 over 6. So put that into your equation for x, so you'll get negative 3y squared plus 1/6 minus the square root of 373 over 6 plus 1 equals 0. So that would give you negative 3y squared equals negative 7/6 plus the square root of 373 over 6, which would have to mean then that y squared equals, again, positive 7/18, this time minus the square root of 373 over 18. Yeah, that should be 18 for the x. I don't know what I was thinking there. So, I mean, that should be 18 for that term. So actually, this y coordinate should have 18 below the square root instead of 6. My bad. But if you look at this is definitely going to be a negative number, right? Because the square root of 73 is, it's darn close to 20. It's just south of 20. 7 minus 20 is definitely negative. So there will be no y solution for the second x coordinate. So your only 2 points of intersection are 1/6 plus the square root of 373 over 6, and then plus and minus the square root of 7/18 plus the square root of 373 over 18. So very nasty solution. Very nasty. But you will have that sometimes when you're solving for the intersection of conic sections. Now, let's see here. What's the next one? We have 10y equals x squared. We have x squared minus 6 equals negative 2y. All right, so 10y equals x squared minus 6 equals negative 2y. This is definitely where the intersection of two parabolas are occurring. I think it's going to help if we move some terms around. So if you simplify the first equation, you could get x squared minus 10y is equal to 0. Simplify your second equation, you could get x squared plus 2y is equal to 6. So that's something much easier to work with. Now it makes it fairly obvious that we probably want to get rid of the x squared, right? So let's subtract the second from the first. You'll be down to negative 12y equals negative 6, which would give you y equals positive 1/2. So we got the y coordinate of a point of intersection. Now, what about the x coordinates, okay? So pick an equation, stick it in. I'm going to put it in my 10, so you would end up getting x squared minus 10 times 1/2 would equal 0, which would give you x squared minus 5 equals 0, which would then give you that x equals plus and minus the square root of 5. So this one didn't work out so bad. So you got 2 points of intersection for these two parabolas where x is both plus and minus the square root of 5, and then y is positive 1/2 for both of them. So those are your 2 points of intersection for these two parabolas. Now I got 2 more, then we're done. Alright, let's see here. What's the next one I wanted to do? So we have x squared plus y squared minus 16x plus 39 equals 0. Then we have x squared minus y squared minus 9 equals 0. So x squared plus y squared minus 16x plus 39 equals 0. That's definitely the equation of a circle. And then x squared minus y squared minus 9 equals 0. That's the equation of a hyperbola. So we got to figure out where a circle and a hyperbola intersect. So I think if we look at this here, we can eliminate the y squared if we add the two equations together, right? So let's go ahead and do just that. You should end up with 2x squared. The y should cancel out. Then you'll have minus 16x plus 30 equals 0. So now, well, we can start by factoring out a common 2. You'll get x squared minus 8x plus 15 equals 0. Which, good news, this will factor just fine into x minus 3 times x minus 5 equals 0. So you get x equals 3 and x equals 5. So you have two x coordinates now for the point of intersection, but what about your y's? Pick an equation and stick those values in for x. So if x1 equals 3, we'll put that into the second equation for simplicity's sake. 3 squared is 9, so that would be 9 minus y squared minus 9 equals 0, which would just mean y squared equals 0. Well, both plus and minus the square root of 0 is 0. So you get y equals 0. So you have a point of intersection at the point 3, 0 for sure. Now, what about when x is 5? So x2 is 5. So 5 squared is 25 minus y squared minus 9 equals 0. Well, that would actually give you y squared equals 16, which means y equals plus and minus 4. So you get 2 more points of intersection. You'll have x for being 5 for both the second points, but y will also be plus and minus 4. So you actually have a total of 3 points of intersection between the circle and the hyperbola. You have 3, 0, and then 5, both plus and minus 4 are your 3 points of intersection. I got just one more here. Alright, so this one, x squared minus y minus 4 equals 0. Then x squared plus 3y squared minus 4y minus 10 equals 0. Alright, so we have x squared minus y minus 4 equals 0, and then x squared plus 3y squared minus 4y minus 10 equals 0. Well, so your first equation's a parabola, your second one's an ellipse. So we're going to figure out where a parabola and an ellipse intersect. I think it's obvious we want to eliminate the x squared if we can. So go ahead and actually, if you want, well, it doesn't matter, I guess. Let's just subtract the second equation. I was going to have us rewrite the order of the equations, but it really doesn't matter. So if you subtract the second from the first, the x terms are gone. You'll end up getting negative 3y squared. Now negative y plus 4y, that's positive 3y. And then negative 4 plus 10, that is plus 6, would equal 0. Well, you can factor out a common negative 3 from this, right? So you should end up getting y squared minus y minus 2 equals 0. Which this should factor into y minus 2 times y plus 1 equals 0. Yep, that's exactly what you get. So you'll have two y values. Y will equal 2 and y will equal negative 1. Now just pick an equation, stick those y values in, see what you get for x. So let's deal with the top equation. I think is easier to do substitution. So our first y is a positive 2. So if we stick that in, you'll get x squared minus 2 minus 4 equals 0. So that's going to give you x squared minus 6 equals 0, which would give you x equals plus and minus the square root of 6. So when y is 2, you'll have two x coordinates of plus and minus the square root of 6, and then your y will be 2 on both of those. So there's 1 point of intersection, or actually 2 points. Now let's pick our second y coordinate of negative 1. So put that into the top equation, you'll get x squared minus 1, that's plus 1, minus 4 equals 0. So that would give you x squared minus 3 equals 0, which would give you x equals plus and minus the square root of 3. So what do you know? You have yet 2 more points of intersection. So for these next two, you'll have two x coordinates of both plus and minus the square root of 3, but your y coordinate will only be negative 1. So this parabola and ellipse have 4 points of intersection at plus and minus the square root of 6, 2, and plus and minus the square root of 3, negative 1. So that's it for this lesson. We got one more lesson left here for this, and actually one more lesson entirely in the conic sections unit. Next lesson we'll do a system of 3 equations that are quadratic. So I hope everyone has a great night. Take care.